When we speak of people's future, we mean after college, the next election, my career, my retirement. When we speak of the universe's future, we mean when the sun burns out, when galaxies collide, when everything flies apart, when all that exists evaporates. The untold billions and trillions of years, you say, make it all irrelevant? Not so. The far, far future of the universe conveys great meaning now. I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out why. I begin in Cambridge, England, at Trinity College, with the UK Astronomer Royal, Sir Martin Rees. Martin's a leader in Big Bang cosmology and galaxy formation, which impel and define the far future. Martin, in seeking to understand what existence is all about, we always start and focus on origins. But perhaps the future is important, or maybe equally important, to understand what it's all about. So if we look to the far future, not just thousands and millions of years, but ultimately, where is the universe going?
Well, of course, long-range forecasts are never too reliable, but let me do my best on that one. Our sun will run out of fuel after 5 or 6 billion years. It'll swell up and become a red giant, engulfing the inner planets, vaporizing any life remaining on Earth, and it'll then settle down as a white dwarf to a quiet death. But any creatures who witness the death of the sun will be as different from us as we are from bacteria. But even the end of the Earth won't be the end of the universe, of course. Many stars will go on shining for much longer. But the galaxy will eventually get much dimmer, because eventually all stars will die and you'll be left with the dead remnants of stars. The universe will also become a much emptier place, because other galaxies which are expanding away from us with the expanding universe, they will accelerate away and disappear beyond our observational horizon. So if you were an astronomer in, say, 100 billion years from now, the only thing you would see will be the remnant of our galaxy and Andromeda and a few other neighbors. All the rest would have disappeared completely beyond your horizon. On a longer time scale even than that, then even atoms don't live forever. We suspect that the individual atoms that make up the stars will gradually erode away in probably 10 to the power 35 years or so. Black holes themselves don't live forever. They evaporate by a very slow process. So after 10 to the power 100 years, even the biggest black holes probably wouldn't exist anymore. And so after that time, we have a universe that is filled with very, very dilute radiation and maybe some stable particles that make up the dark matter, and that'll be it. So that's the simplest story. But it could be wrong for many, many reasons, of course. One possibility is that the force which drives the accelerating expansion may be more complicated than we think. It may change, it may get stronger, in which case it would tear apart even stars. But the forecast does seem to be for an ever colder, ever emptier universe. And to quote Woody Allen, eternity is very long, especially towards the end. And so that is the scenario we have. But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
But certainly the gloomy forecast of a universe that is totally dissolute of matter has been reinforced by the notion that the expansion of the universe is accelerating.
That's right, but let's not forget that the timescales we're talking about here are so hugely long compared to any timescale for biological evolution. And so long before this happens, then there could be entities of superhuman intelligence, either organic or maybe based on some sort of artifacts made by organic creatures.
Some have speculated wildly that those post-humans in the future, biological or machine, would be so advanced that they might even be able to alter the space-time of the universe to prevent that ultimate dissolution. Is that even conceivably true?
Well, science fiction writers can conceive of it, and that's all we can hope for, because, of course, it would have been hard for people 1,000 years ago to conceive of present concept of the universe, and we're now talking not just about thousands of years, but about billions of years, so we can't conceive at all what will happen then. And I believe that as science advances, its frontiers get longer and more new questions come into focus. And the questions which scientists will be talking about 50 or 100 years from now are questions we can't even formulate. And that's just a century. So when we talk about what might happen in this longer range future, then I think we can't do better than the science fiction writers.
The sun exhausts its fuel. Galaxies fade away. All eventually is gone. It's strange. The universe dissipates after trillions of years, and I feel empty now, alone, cold. Why? An existential vacuum of meaning and purpose? A brutal confrontation with an indifferent reality? That human beings, so terribly limited by space and time, can imagine the universe in the far, far future by measuring its expansion today is astonishing. I go to Pasadena, to the Carnegie Observatories, to meet its director, Wendy Freedman, who discovered the rate of universal expansion.
We observe that the universe is expanding at the current time. What astronomers have found over the last decade is that the universe is actually speeding up in its expansion. It's accelerating over time. Objects, supernovae, very bright objects, we've made measurements that show that they're further away than we would have expected if the universe were slowing down. So there now appears to be, in fact, a growing body of evidence for this acceleration of the universe. But what it says is that we are actually living at a unique time when we can see many galaxies in the universe that will actually go outside of the radius over which we will be able to measure light traveling to us over. They will actually go beyond our visible light horizon. So the universe will appear to get emptier and emptier with time. You know, in the future, if we were born and came out and looked at the universe, we wouldn't see the same universe that we see today. There'll be a lot fewer galaxies within our horizon. So it's a time when the acceleration now is becoming this component of dark energy is the dominant component in the universe. And we're seeing for the first time where the effects of this acceleration are starting.
It's a funny emotion because it is exhilarating to be able to experience that and to feel that, and at the same time it is rather bleak if you think of where it's all heading.
I don't think we can predict when we don't know the properties of this matter. Maybe it decays. This dark energy has some funny property that maybe the universe will stop accelerating and it will start contracting.
The only way to get it back together is to assume things will happen in the future that are not indicated now through changing law of some
That's
kind.
right. Since we don't know what changed to give us the dark energy, what the dark energy is, we can't make predictions for the future. We really, I think, lost the predictive power of the relation between the expansion and the future.
So is our time really special, with innumerable galaxies within sphere of view, with understanding cosmic expansion? We're heading inexorably to the far, far future. But what's the next big event? Over the horizon, what's coming? In Iceland, with scientists contemplating the universe, I meet Harvard astrophysicist Avi Loeb, originally from Israel. Avi's an expert on galactic structures, and I hear tell of a galactic collision. Avi, when you think about the future, you think about what's going to happen when our galaxy collides with our neighboring galaxy.
That's correct. If you look at a galaxy far away from us, it not only expands away from us, but the rate by which it expands away from us is growing with time. And what that means is that eventually this galaxy will run away from us at a speed that may exceed the speed of light. And we will not be able to receive any signals from such a galaxy. So in fact, one can run the movie forward in time and ask which of the galaxies that we see around us will stay bound to us and not participate in this cosmic acceleration. It turns out that only the Andromeda galaxy will remain bound to us. And not only that, but the Andromeda galaxy is approaching us right now. And what we found is that within 2 billion years, the two galaxies will come very close to each other. That will be the first encounter with Andromeda. We found that there is some chance that the sun will be stolen by the Andromeda galaxy so that subsequently we would see the Milky Way as an external galaxy. But most likely we will remain bound to the Milky Way. The solar system will be just kicked a little bit as a result of this first encounter. And the Andromeda galaxy will pass near us and then come back again a couple of billion years later. And eventually the two galaxies will mix.
Eventually is how long?
Less than 5 billion years from now. So in fact, the sun will still be alive at that point in time. We found that the collision will end before the sun will consume all of its nuclear fuel.
Now, when both of these galaxies collide, there's so much space there that the likelihood of stars within them actually crashing into one another is very
small.
low.
It's very small, it's minuscule, but the stars will be mixed up in a way that instead of having two disks of stars organized in a plane, one will get a ball of stars that has the shape roughly of an ellipsoid. We see galaxies like that. They are called elliptical galaxies. And the popular explanation for their existence is that they resulted from a merger of two disk galaxies. The reason that this collision is interesting is because this merger product of the collision between the Milky Way and Andromeda will be the only galaxy that we will be able to see in the distant future. And so tens of billions of years from now, there will be no other object on the sky for us to observe. There will be just this merger product, which we termed Milkomeda, the Milky Way and Andromeda merger product. Subsequently, we will have nothing else to observe, and we will have to rely on the data that we collected up to this time.
Talk about planning for the future. Nobody's thinking farther than Avi. Don't let the flowery words lull you. The far, far future is utterly bleak. But guess what? Our future could be bleaker still. Anxiously, I go to Tufts University in Boston to meet cosmologist Alexander Vilenkin, originally from Russia. Alex suggests how the universe might have begun from literally nothing. What about how the universe might ultimately end? Alex, the common perception today among cosmologists, physicists, is that the accelerating expansion of the universe means for sure that not only will the expansion continue forever, but the amount of matter will get more dilute and more diffuse so that eventually all we'll have is random photons and running around without any sense of organization whatsoever. And that's it. What do you think?
Well, I think that what you described is going to happen, but if you ask me, I don't think this is how it's going to end. The very end is going to be somewhat different. The reason we have now this accelerated expansion is because our vacuum has non-zero energy. And the energy of the vacuum creates repulsive gravity, and the universe expands with acceleration.
And this is through all space, this negative gravity, this repulsive gravity.
The cosmology now suggests a picture of a multiverse, which suggests that in addition to our region, there are other regions where the vacuum energy has different value. So what's important for our discussion here is not the existence of those other regions, but the possibility for a vacuum to have a different energy, in particular negative energy. And now we have this positive energy. However, since there is a possibility to lower the energy, in physics, when there is a possibility to lower the energy, this happens sooner or later, in one way or the other. And the way this is likely to happen is that a tiny bubble of negative energy vacuum will pop out somewhere in space, just like a bubble of vapor pops out in a boiling water. And this bubble will start to expand. Its expansion will accelerate, so it will expand faster and faster, approaching the speed of light. And eventually we'll be hit by that bubble. So not probably we, because we will be long gone and the stars will be dead and so forth. So this probability for such bubble nucleation is usually extremely small. So there is a lot of time, there is nothing immediate to worry about. But our region is likely to be overcome by this bubble of negative energy vacuum. And once whatever matter is left will be turned into blobs of some alien form of matter which can exist only in that vacuum. And a negative energy vacuum, instead of repulsive gravity, has a very strongly attractive gravity. So the interior of that bubble will collapse to a big crunch.
It
eats up, right.
It eats everything in its way. It's like the ultimate monster.
That's right.
And it eats everything in its way, and it consumes everything and grows in power.
Which moves faster and faster as a result.
The more it eats, the stronger it gets.
That's right. So this will be the end of our region, but I should say this will not be the end of the entire universe.
Because if every region is hit by a bubble, all these infinite numbers of universes are hit by their own bubble, but the generation of multiple universes continues forever as well. So
that's right, and the generation wins.
So there's ultimate hope, even though there's ultimate certainty that each observable region will eventually get eaten. There's certainty that many more will always exist.
That's right.
I get that right?
Yes. That's not an easy one.
Bleak, bleaker, bleakest. Pick your poison. That's the scientific certainty. Unless, of course, there's a radically different kind of future in store for us. A future conceived by hope, though ridiculed by science. This is the uncharted territory of Robert John Russell, an ordained minister with a doctorate in physics. Bob is founder of the Center for Theology and the Natural Sciences in Berkeley. I'd love to believe as Bob believes, if only my wishes had powers. Bob, what is the far, far, far future for reality? Yeah. I hear the cosmologists tell me, and it's a pretty bleak story as the universe expands in its accelerating mode. And, of course, I'm familiar with the religious views of Judaism, Christianity, Islam that paints a very different picture of God's intervention. What do I do with this conflict?
Well, it's a huge question. The heart of the biblical message is that the God who saves is the God who creates, and that part of creation is broken. There's death, disease, there's human folly and arrogance and sin. So creation isn't complete. It has a future in which those will be gone. And that's the hope I think we share as Christians and Jews, that there really will be a future for all of earth and not just humankind. That is a lion and a lamb laying down together, right? A true New Jerusalem. Now the problem is the conflict, right?
And how we get there. If there really is a God, and we know the physical world is real, how that God would transform this physical world.
Well, there are lots of approaches to it. I mean, my favorite approach is to say, look, the laws of nature that we reflect in, say, physics and Big Bang cosmology that predict the freezer-fry scenarios, those laws of nature ultimately depend upon God's regular action. Science assumes they're autonomous, but below that, I see God acting.
The freezer-fry, meaning is the world going to expand forever and freeze, or collapse in a big crunch and
huge heat and everybody
Exactly.
dies. Either way, everybody dies.
In fact, in either case, life as we know it is impossible in the near far future, in a trillion years. I mean, it's way before that. So either way, it's not good.
All right. So how does God get involved in this process?
Well, God's always involved in the world because God's the creator.
But he's going to do something new.
Yes.
Okay. How's he going to do it?
Well, if I every single day for 10 years ate a chicken sandwich for lunch, you could probably predict I'd eat one the next day, right, after 10 years. But I might not. I might have roast beef. Or I might become a vegetarian, right? If God is acting in a regular way, and we predict the future on those actions, but if God does choose to act differently, God doesn't violate the laws of nature, and the predictions of science aren't wrong in some technical sense that they made the equations wrong. It's just that we're in a new ballgame. God is acting in a new way. Now, for Christians like myself, the resurrection of Christ on Sunday, Easter, is the beginning of a new creation. That's what that's about for me. And so that's saying, in Christ's death and resurrection, death itself has died, is the way you
So that's your test case. That's your prototype.
That's my test case, exactly.
So how would you generalize that? I'll assume that I'll go with you on your assumption.
Okay.
How do you then generalize from your prototype into a creation of a new heavens and a new earth?
Well, it's not a total new creation. It isn't a second ex nihilo out of nothing.
Okay.
It's a continuation of this world. After all, Jesus was Jesus. He could be recognized, he could be touched, he made breakfast, right? But he's also this transcendent Lord who is sort of beyond space and time, yet within it. So if that's the future, and the future sort of in the present, then it must mean there's something about this universe which is continuous with the future universe. It's not snatch and grab. It's not you walk off to heaven and forget the universe. God loves God's creation, everything about it. All of it will be cherished forever in a new creation. So somehow you deploy that. The word transformation is perfect because it means there's continuity and discontinuity.
So let's go into each one of those. What kinds of continuities and what kinds of discontinuities?
Well, in evolution, mostly you have continuity. The laws of physics are the same for 15 billion years, but biology emerges. This is the other way around. The discontinuity is huge. Jesus brought back Lazarus from the dead, but Lazarus still died. So that's not resurrection, that's resuscitation. Presumably, Jesus didn't die again. He's resurrected. So that's a radical change, but it's still Jesus. So that's an element of continuity. Now, if that's the case, and if it's for the future of the universe, there must be elements of the universe now that will be continuous with the future universe, and there must be parts that are discontinuous. And that's where science might come in, because if we had some clue as to what's continuous, what's of true value, like agape love, or the Pythagorean theorem, right? Or the joy of living, or the joy of being physical. I mean, appreciating love and reality and sexuality and earthiness, all of those are grounded in God's creation and new creation. At the same time, suffering and disease and inhumanity, right, and predatory cycle and entropy wearing things down, all of those things seem not to reflect God's grace and goodness for life, but seem to be at a cost, kind of the tragic side of life. And those couldn't be in the new creation.
So seeing that, how do you then generalize from that prototype to all reality? What will it be in the new creation, the transformation of the heavens and the earth?
Well, I think you can say it will be all that's good about this creation, all that's good about physicality, right? All that we enjoy as physical, embodied, real creatures, not as a trapped soul and not just as an animal, but as a truly embodied person in community. All of that, all the agape experience of that, all the love experience of that will be present. So the universe itself has that as a destiny.
If you're right, I hope to see you there.
You will. I'll see you too.
How much we know about the far, far future, observing in advance, as it were, billions and trillions of years to come. The likely scenario is that the universe will expand forever, stretched apart by an increasingly powerful dark energy, so that the ultimate future is random radiation, nothing more. Yet the science is still young. But either way, freeze or fry, expand into frigid infinite emptiness, or collapse into the torrid singularity of a big crunch, the universe's future seems bereft of joy and devoid of hope. Religion offers alternatives, a great transformation, a new heavens and a new earth. I yearn to believe, but facts fight faith. I turn again to Martin Rees.
Science fiction writers are our best guide at the moment, and more generally, I would say that first-rate science fiction is a greater stimulus than second-rate science in discussing all these issues.
No matter what, seeking the far, far future brings us closer to truth.
For complete interviews and for further information, please visit closertotruth.com.